Hey future nurses, I'm your fellow nurse. Welcome back to Smart Scrubs. I created video yesterday regarding sodium potassium pump, but I wasn't fully satisfied with my video. I wanted to include short description that you can go through just right before your exam, or you can keep it handy in case you need it for your exams or just for your school preparation. So I'm going to create another video which is a short description, and it will give you a short intro about sodium potassium pump. So this image that you can see on my screen is actually the cell wall. You can see extracellular fluid there and cytoplasm, and the pump is embedded in the cell wall. So you can see how it looks like. The function of this pump is it actively transports 3 sodium ions out of the cell and 2 potassium ions into the cell against their concentration gradient. The process is powered by the hydrolysis of ATP and ADP. ATP is adenosine triphosphate, and ADP is adenosine diphosphate. Those are the energy molecules, and inorganic phosphate. And I will show you another image that shows how the whole process works. And this pump is embedded within the cell membrane, separating the cytoplasm, intracellular fluid, and extracellular fluid. It plays vital role in maintaining cell volume, nerve impulse transmission, and muscle contraction by establishing and maintaining the electrochemical gradient of sodium and potassium ions across the cell membrane. So in these two images, you can actually see how the pump works. So you can see in pump, they have um, the respected places for sodium and potassium. So as you can see, when sodium attached to those receptors, it go out, and then the potassium attached to its receptor and then come back. So you can see both of those have two different shapes. And on the first one, where you can see pink sodium and yellow potassium, and you can also see there's a phosphate attaching to the pump, which actually helping the pump to throw sodium out and potassium in the cell. So this pump is like a bouncer of the cell, kicking out sodium and letting in potassium to set up action potential for your heart and nerve. Its job is to pump 3 sodium ions out of the cell and 2 potassium ions in, using ATP as its energy source. This creates a gradient: high sodium outside, high potassium inside, and a negative charge inside the cell around negative 70 millivolts, called the resting membrane potential. So this graph shows the whole sodium potassium pump activity and how it generate action potential. So resting membrane potential, as I mentioned several times before, the neuron is in its resting state with the negative electrical charge inside relative to the outside. This potential is maintained by ion pumps and the membrane's permeability to potassium ions. So here you can see at the bottom where it says negative 70. This is the resting potential. This is where we are in the beginning of the cycle, and this is where the cell is. And as the sodium channels open, sodium begins to enter the cell. The graph, you can see the blue line, it's going up and up. So you will see it's getting excited. A stimulus such as neurotransmitter binding to dendrite, causing a small change in membrane potential. If this polarization reach a critical level called the threshold of excitation, which is um, on the top where you can see number 3, it triggers the opening of voltage gated sodium channels. Sodium ions rapidly rush into the cell, causing the inside of the membrane to become increasingly positive. This rapid rise in positive charge is the rising phase of action potential. So you can see how the graph is going up, point 1, 2, 3. All the channels will open one by one. So sodium channel open, sodium begins to enter the cell, and then potassium channel open, potassium begins to leave the cell, and then sodium channel become refractory, no more sodium enters the cell because now we have enough charge on a cell. So you can see plus 30. So it went from negative 70 to plus 30. And there, because we have enough positive charge, it will generate action potential. And then after the generation of action potential, repolarization occurs. So you can see at the bottom graph where you can see red line that shows the depolarization, where we have all the channels opens, ions go in and out, and then it generate action potential when it reach to certain level. And after the action potential, it repolarize because it's the action potential generated. Now the positive charge will come down back to negative, which is repolarization. As the membrane potential peaks, the sodium channel begin to close, the voltage gated potassium channels open, allowing potassium ions to flow out of the cell down their chemical gradient, the electrochemical gradient. The outflow of positive potassium ions causes the membrane potential to become negative again, a process called repolarization, right? And then hyperpolarization, which is undershoot. So you can see when the graph line it go down further than negative 70, that is hyperpolarization. The potassium channels remain open for a brief period after repolarization is complete. This lead to an excessive outflow of potassium ions, causing the membrane potential to become more negative than the resting potential. This phase is known as hyperpolarization. And then come back to the resting potential. It returned to resting potential. The potassium channels finally close. The sodium potassium pump and other ion transporters restore the original ion balance across the membrane, re-establishing the resting membrane potential. The neuron is now ready to fire another action potential if a sufficient stimulus is received. So you can see we were at negative 70 before. As the channels open, the sodium begins to enter the cell, potassium begins to leave the cell. The graph go up to 30 or 40. It's actually positive 30 where the action potential generates, and then after the action potential it come down further down than negative 70 because our potassium channel is it's still open. So it come further down to negative 70, and then after the potassium channels close, it come back to resting state, and this whole cycle keep going on because our neurons need action potential to generate the nerve signals. uh, this is how our nerve cells pass on the message to the brain, from brain to the body. So this whole cycle keep going on. If it's this cycle is working, that's why our body is working. So this is a quick review of the sodium potassium channel. I hope you liked this video. If you liked it, please like, comment, and subscribe. And let me know um, if you want me to make another video, like a different video for a different topic. And see you guys later. Bye.